Gateway to the Future, Brief History of Kubernetes Ingress. I would like to have it a little bit on interactive side of things and more showing rather than telling and showing you slides. Kubernetes networking is, I'm not going to say notoriously difficult. It is complex. There's a lot of things going on, and many things are maybe not exposed directly to users. This is kind of like a introductory and talk that gives you understanding how the things are progressing from one point to another point. And if you would be interested, let us know. We can go deeper in some of the more advanced topics, but this one is more accessible for everyone. And if you don't have much of experience, you will learn a lot of things. If you have a little bit of experience, I'll try to show some of the progression, how all this networking API inside Kubernetes came about. So that's the essence of our today's conversation. So what is happening when you're using your curl or using your browser or using like whatever tool that you're trying to access any service, in this case concproxy.me, and how those traffics are going from a point where you start doing curling to this. Actually, you can even try this right now. This URL should be up and running. You should be able to do curl, and you can see some funny facts about Chuck Norris. And in this presentation, I'll show you how this traffic will traverse from point of ingress, where the thing is that we'll be providing the gateway into our application, how this would be routed inside the service, and how my replicas of my application that runs inside Kubernetes will be responsible for this one. As Dalia mentioned, my name is Viktor Gamov. I work as a principal developer advocate here with Conk. You've probably seen some of the videos of me doing this on a Conk YouTube channel, so I'm happy to share some of the technical details about what things we do at Conk and how our tools help you to build applications. Briefly talk about Kubernetes in networking, how this application work. We'll talk a little bit about Ingress, some of the limitations of Ingress regarding to certain capabilities that modern application require, and where we're going beyond Ingress, like what's going to be next bright future for next couple years, hopefully. So that is it. So let's talk about how all things come together. So in the very beginning, when you deploy your applications, Kubernetes is the system that you tell it what you want, how the state of the galaxy, how the state of your application would look like, and Kubernetes will make it happen. So essentially, you define your deployment where you specify how many pods you want to deploy, and you usually don't tell Kubernetes how you want these things to be deployed. Those things will be taken care of by Kubernetes. So we have 3 nodes of Kubernetes cluster. This is a physical nodes, or it can be virtual machines or what have you. It's like a Kubernetes clustered nodes. And those nodes are create this Kubernetes cluster that we will deploy in our apps. And if I want to deploy some apps there, I want to deploy, say, orders app with replication factor 3, meaning that there would be 3 replicas in my deployment, and Kubernetes will take and balance this out across multiple nodes. So in order these applications will be accessible starting from within Kubernetes cluster, we need to define a service. Service, it's going to be internal load balancer that allows to the service will be discoverable. Let me quickly show you how this looks like in real life. So I have my Kubernetes cluster running right now, and in my default namespace, I have a bunch of services: Back to Future quad service, Chuck Norris quad service, Dune, and some sort of like a default Kubernetes service. Some of the things you can see here is this cluster IP, and the cluster IP, it's where the service can be routed from within Kubernetes cluster. One of the things, how you can expose this, like you either have a pod in your Kubernetes cluster, you log into the pod and using the curl URL, so you will be able to use this IP address to hit this quad service. Another option would be using something like a port forwarding that creates a tunnel between my machine and Kubernetes cluster. So let's do something like this. So for example, if I will just go ahead and create this port forward for this quad service, what I will be able to do, so I will be able to do something like this. If I will just do HTTP to localhost, I'll get the answer from my Back to Future quad service. So the way how it works, internally, Kubernetes will create a tunnel between my computer because I'm running Kubernetes client inside my computer and between the actual application. This thing is not very useful if you try to share your application with someone else. It's good for debugging, good for demos, but if you want to expose this application to outside world, you need to do something else. And this is where we're going into the world of the load balancer. Some of the services might have a different types. One of the types of the services we all just saw is called cluster IP, meaning that inside the cluster it would be routed. If you want to have ability to route the traffic from your application to from outside world, you need to have a different type of the service. If I go back to my K9S client, one of the types I can see here is cluster IP. But if I go ahead, say, I will edit this service and do something like this. I change the type. Say, load balancer. I will save it. And what will happen in a few seconds, since I'm running this managed Kubernetes cluster, I will get actual external IP to my service that will be routed from anywhere in the world. So I don't need to have port forwarding to the service anymore. I don't have to do anything. So I can take this IP address and share it from anywhere in the world. So just we will give a few seconds to this external IP to be provided. And this is exactly what I was talking about. So that's the external IP that I will be able to. Sorry. And I'm going back to my default namespace. Yeah. So now I will be able to. So now I will be able to use this across my application. So if I will take this IP address like this one and go to my HTTP, so I'll just do HTTP. In this case, should give me a response back from my Back to Future service. Probably it's not available yet, even though IP address is provided. Yes, of course. So I need to also provide the port. So as you can see here, now with type of load balancer, it will be able to get access to this one. Does the load balancer type balances traffic across many pod instances? Very good question, Francisco. So let me show you how this actually works. In my service, this particular service that I have right now, my Back to Future quote service, right now it is backed by one deployment that has, Back to Future service, I have one deployment that has only one replica. So what will happen if I will put the two replicas here? In this case, my Kubernetes cluster will read this configuration and spin up another a pod for my application. And watch here, I have a very special type of header that will be responded from my pod. So in this particular case, every time when I will be hitting this load balancer service, I would know which pod will be responding with this response. So right now, watch the name. So in this case, it's gonna be 7C66 blah blah blah. If I will try to do this one more time, I will get the answer from the same pod. But when I call this second time and a few more times, should be now. It should be, let's see if, now the response came in from the different pod. When I created this load balancer service inside my Kubernetes cluster, it also created an internal load balancer, and the traffic will be bounced between these two pods. And as far as I can tell, default mode is round robin, so 50% of the traffic will go to one, 50% of the traffic will go to another one, but sometimes it works, sometimes it doesn't, so there would be some of the things that can be done. So to answer this question, when we created this load balancer service, it will naturally load balance across all the replicas. Now, so that's the first step. How you want to do this? The first step of how we can approach this exposing external services. So what is happening when you're trying to create more services? You deploy more applications. So you have orders, you have bills, analytics, blah, 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 some other services. So you think about this, okay, I would just create a load balancer service for everyone. So in this case, all the services will be available to outside world. Sounds like a good idea on the start, but you think about this number of IP addresses that are available in the real life might be limited. Sometimes you want to have a centralized control. Sometimes you don't want to create every time when the service will be exposed to to outside world. You don't want to have the ability to export the service to outside world. You want to have something internal, but also accessible somehow. So over the time, Kubernetes community come up with this idea of Kubernetes Ingress. So essentially putting the proxy in front of this, and this proxy will be responsible for routing this traffic. So from now on, we're going to be talking not about load balancer service. We're going to be talking about another type of the object that's available in Kubernetes cluster called Ingress object. So now let's talk about this one. So essentially what it does, it creates a declarative configuration for some sort of proxy that sits in front on every request, and this proxy will be responsible for routing traffic. As you can see here from the point where I'm sitting, there's a few things that you need to specify in this specification. One of the things is rules, how the traffic will be routed from particular path or from particular host. As you can see here, there's a host, there's a path, to particular service. So you don't need to now define your service as a load balancer. So what you can do is you define the service as a cluster IP. So this service needs to be routed within Kubernetes cluster. And one of the things that this Ingress would be responsible for exposing those service through some sort of proxy. There's a few things that you don't see here. And those things feel like a little bit about magic because you're not specifying. You don't know what kind of proxy does the thing. You don't see what is going on in terms of like how you configure this proxy and where this proxy came from. So the way how it works inside the Kubernetes cluster, when you apply this Ingress object, Kubernetes API server will talk to so-called Ingress controller. So Ingress controller, that's special type of Kubernetes application that will be running inside your Kubernetes cluster. And this Ingress controller will be responsible for, first of all, parsing this Ingress object and creating the rules of how this traffic will traverse from the request into the point where it needs to reach particular service inside your Kubernetes cluster. And we at Kong happen to have one of these Ingress controllers. Naturally, it's called Kong Ingress controller. It is an open source tool. Many of you probably have seen this. So if you go to Kong, GitHub Kong, and if you go into GitHub for Kong, you can see one of the pinned project here. It's called Kong Ingress controller. That's the Ingress controller for Kubernetes. Once you install it, you will be able to do certain cool things. There's a plenty of other Ingress controllers available. There's many people use Nginx as an Ingress controller. Some other people using different type of ingresses. So I'm going to be naturally you're on the Kong channel, and naturally we're going to be talking about Kong Ingress controller for that matter. Kong Ingress controller become a quite sophisticated tool for managing all possible configurations. And today I'm going to be also showing the Kong Ingress controller with conjunction of some of the cool service that we develop here at Kong called Kong Connect, and my Kong Ingress controller connecting to Kong Connect, so I will be able to see and show all the configuration that we will be doing today in a very nice UI. As a proxy that will be responsible for this can be any underlying technology. And as this proxy, we're going to be using Kong Gateway. So Kong Ingress controller will be responsible for reading Kubernetes the definitions and translate this configuration into Kong configuration. So as a developer, as a user of this, you don't have to go and configure Kong Gateway manually, because Kong Ingress controller will be responsible translating this vendor-independent configuration that I showed you, vendor-independent spec, this particular spec, into something that would be related to Kong. And I will show you how this would look like. So many of you know Kong is one of the most popular gateway available there, and with power of Kubernetes, Kong is also becomes one of the most popular cloud native gateways that can serve some of your load. And we're going to see how we can use power of Kong in this setting with Kubernetes. So let's see some code. So let's start with small. We will continue my Back to Future example. In this particular case, I do have a ingress. So let me hide this for now, so you will not see anything else. So we have a Kubernetes. I have a Kubernetes ingress. This ingress is will be serving the traffic every time when I need to hit this back to future conk.proxy, in this case, I will be getting access to my quote service. Remember, I showed you first time how we can do this with the port forwarding. After that, I showed you how I modified this quote back to future quote service. So it will have its own IP address. And now, so I will have an ingress as an entry point to every application. So one ingress will be serving everything that I will be, all the services that I need to expose will be served through the conk ingress. One of the things that you notice here, and this is the part of specification, this is where inside specification, you need to tell that there's a specific ingress class that will be specific ingress controller that will be serving this. So let's take a look on the services. So in order to my conk ingress controller, in order to my conk proxy will be available, so it is deployed as a load balancer now. So all traffic can go to this point. So if I will go here and I just do, it gives me answer that no routes match to those values. It's because right now with this request, my conk gateway doesn't know how to hit the service. And in my configuration for my ingress, I define this host inside my rule. So based on the host name, my API gateway will be able to run this. So inside, if I want to use something like HTTP, and I want to use something like, I want to route this thing into my back to future service, I need to specify host header. So when I hit here, you see here what happened. My request now landed into back to future pod. So if I'll call it a few times, as you can see here, and response is also load balanced because we have two pods that run this back to future service. And what we can tell it's back to future because where's the Marty? Gigawatt. Gigawatt. Write down in the comments if you remember what the hell is gigawatt. Now, so now we will be able to create multiple different services, and all the services will go from the one single point of entry. In this case, it's going to be our ingress, aka conk gateway, that will be responsible for doing some cool things here. Overshadowing, we do have, you can see some of the rate limiting headers, and I will talk about this in a second. So now I also want to have another service. This service will serving a facts about a very famous internet character and one of my favorite movie stars of 90s, Chuck Norris. So the Chuck quote service also have the same architecture as Back to Future quote service. It has a deployment, it has a service, and now I want to serve this through this host. I can go and do something like, let me put this on the screen so you will be able to see this in the center of your screen. So what I can do here, if I go and say Chuck, it says no API key found. It's just a reason for that because I already jumped in front of the gun. But the service is there, so I'm getting the answer from the Chuck Norris and things like that. Oh no, actually we're not getting the answer from the Chuck Norris because the API gateway short-circuited my call. So let me fix that before we jump any further. Some people can say that, okay, so Viktor, but it's a little bit cumbersome to every time to put this like host header. Can we do better? Yes, we can. If you have a DNS configured in your future, if you have a DNS configured in your environment and you have a control over, I have this control over this proxy, conk-proxy.me domain, so I can create as many services there as well. So as you can see here, if I will call this directly, and now if I will go and do something like back to future, so the dig command allows me to get the DNS resolution between DNS name and IP address. And as you can see, it's our 200 IP address that points to my API gateway. So as you can see here, for different host names, I still have a one single IP address. So it goes to the same place. It goes to the same API gateway. So I can have a centralized control. So Back to Future is available. Some of the plugins already configured. And some of you can ask me, Victor, but how I can configure this plugins? Inside my Ingress class, I'm able to put as many things as I want, as many annotation as I want. And the way how we use this in terms of configuring some of the gateway-specific things, conc-specific things, is using annotation. So in this particular case, I'm using few annotations. So I'm using this strip path annotation, and I'm using this annotation for plugins. Also, I use this very cool tool that is an open source tool called External DNS that allows me to configure my DNS on the fly. So in this case, when I'm creating this ingress and I'm putting this annotation for the host name, my external DNS system will go to my DNS provider and create this back to future a record pointed to my API gateway IP address. So I don't have to configure those DNS service myself. So let's talk about this plugin thing. So rate limiting free. When I'm going into plugins, I'm going to rate limiting free tier. And as you can see here, it's also YAML, and this YAML is also Kubernetes related YAML because this is how we're configuring things in Kubernetes. We're using this custom resource definition. And if I will go here and say get conc plugins, now my Kubernetes also know a little bit about this CRD. So if I'll just do get and I'll say plugin. So I do have a conc registered conc plugin and conc cluster plugin. Cluster plugin can be applied for whole routes and services, and the plugins can be applied to routes, applied to services, and so forth and so on. So let's play around with this thing a little bit. I have a plugin that is defined and deployed in my Kubernetes cluster, and my Ingress now also use this as a kind of like a reference. I created plugin called rate free tier, so all requests that will go to this to the service will have rate limiting. So in this particular case. Yes, Carl, rate limiting is quite popular topic these days. Hashtag rate limit exceeded. And I'm thinking to do more deep dives in this topic, how rate limiting works, how you can configure across the multiple places, including on gateway, on service mesh. So write down in the comments if you will be interested in this type of content that we can publish and talk about this. So rate limiting free. So in this case, by every IP address, I only allow 5 requests per minute, and that there's a local policy means that information about the sliding window for this rate limiting will be stored in memory of conc gateway. We also support Redis as a storage for this. Now, let's take a look how this actually works. For this, I will bring my my favorite tool for calling the things, specifically put the denial of service type of attacks. And Insomnia has this feature called repeat on interval. So instead of me hitting this F5 on my browser or calling these things every time, I will use Insomnia, and Insomnia will call this stuff for me. So we're getting responses. And after 5 responses, we start getting too many request response. So we get the rate limited. Now my service is rate limited, and the sliding window is related to the time on the server. Like sliding window for every 60 seconds, we will have a 5 requests. So when I was talking about this Connect thingy, one of the cool things that Connect has is analytic thing that can show me the traffic, how it goes into my application. So I called my service a few times, and now I start getting errors. So this thing very handy to see what is going on with my application. By the way, Connect is if you want to get this type of like functionality, I will post the code at the end, so you can sign up for free. And you will be able to use Conc Ingress controller with Connect for free with analytics and all this kind of stuff. So let's go from this point. Let's get back to Chuck Norris. So one of the things that you can notice here, if I will hit this Chuck Norris service one more time, I'll just do Chuck and I'll just do this. I'm getting something like no API key found in request. How does it work? So in Chuck Norris Ingress service, I have quite a few annotations as well. Also strip path is because it's required for my application, because my application is very sensitive to whatever I send it into an input. So in this case, Conga takes care of this for me. Also, my Chuck Norris endpoint includes 3 different plugins configured on one service route. So in this case, let's take a look how this looks like. So first of all, let's take a look on the rate pay tier. So I have a configuration for my rate limiting that has a tiering. So in this particular case, I want to have a consumer that has API key, will have 10 requests per minute. And also using this, like instead of IP address, I'm using this consumer. And the way how I identify this consumer, I need to provide API key. So if I will call my Chuck Norris service, going into Chuck Norris service, when I call this, still gets API not found. But if I will go and configure this API key as a part of my header, so I'm doing this API key, and the header, the API key is a please with praying emoji. So I will be able to do the thing. So, and I also will be using Insomnia to repeat on interval. So every second, we should get the 10 requests, and only after that, we should be able to see how the system will bail. So if I'm going to my gateway services back and going with the Chuck Norris quote service, so first of all, I see there's the route where I have a plugin configured, and I have all these 3 plugins configured across my, let me do this a little bit bigger. Yeah, so I have a key authentication, and I have 2 rate limiting plugin configured. One is the paid tier, and another one is platinum tier. We're going to talk about platinum tier in a second. But for analytics, what we can see right now, some of the requests are going with the 200, which is, good. Some of the requests were going 409. Remember this responses that we get that has unauthorized exception. So we're also capturing this request as well. And also we can see 429 is a rate limiting limit exception. So now I want to have ability for some of the customers who pay me or have a blue mark. Remember, since we're talking on Twitter side of things, so someone will have a blue mark and they might have more requests for Chuck Norris service. So in this case, I do have a platinum tier. For the platinum tier, I have exactly the same configuration for this plugin, but only difference is that I have a different API key. So if you providing me with different API key, and I can tell you that you belong to a different tier, you will get 100 requests within the minute. So let's take a look how this will work. Repeat on interval, go 100. And we were using the run house kick as our keyword. And now every header of this response also will include information about rate limiting. How many requests I have? Let me stop this because this blinking is distracting. So rate limiting 100 requests. We're getting how many requests remained, and in the how soon this rate limit would be. So I'll show you here. So first of all, we're talking about how many requests we have per minute, like this one. Let's use something like a free drawing thing. We see how many we have, how many remained, and this is how much time we need to wait until this thing will reset. So this is the part of the configuration that we have on the plugin. More advanced configurations of the plugin, we can talk about this in the next videos or next presentations. Might include some more auto configuration based on, I don't know, like if you have a OIDC provider configured, and based on OIDC provider scope, you will be able to configure for different users. They might have a different SLA for this call. So that's the thing with this rate limiting. So let's try to do send one more time. It's still working. We're getting responses, and so everything is good. Is Ingress controller level 4 or level 7 implementation? We're going to talk about level 4 in a second. Before I jump into level 4, I want to show you one more thing in the level 7. Many of users, write down in the comments if you're excited about gRPC, because gRPC is also a pretty cool piece of technology that allows you to do level 7 workloads, but also a benefit from having like a high speed, not text-based binary protocol. So I do have another service that is implemented in is a quote service, and this quote service sends the data from one of my favorite sci-fi books all the time, Dune. And this service also available from within my Ingress controller. And this is where it actually really shows the capabilities, and we really push into capabilities of this API gateway, serving not only HTTP, HTTPS traffic, but also gRPC. Remember, when the Ingress object was created in the very beginning, people always focused on the HTTP and HTTPS workloads, because it's kind of like a natural to talk about REST API. But over the time, people start pushing the envelope and trying to use different services. Specifically, gRPC requires some of the customization. So let me quickly show you Ingress for my gRPC service. So if I'm going to Dune, from perspective of specification, everything looks pretty much the same. I'm also showing here how I can use HTTPS on top of this in using the provision certificates using cert manager. So in this particular case, cert manager will be issuing certificate for my gRPC service. And few annotations that I need to put in front. One of the annotations here is the protocol. So in order to, if I will go and do this stuff like with HTTP client, I'll just do HTTP and I'll just do Dune conproxy.me. So what I will get, I'll get the response unsupported media type. So I'm trying to using the HTTP client and hitting to gRPC route. So I need to tell API gateway that all the clients that will be connecting to this service would need to use HTTP2 and the gRPC protocol. So HTTP is not working here, so I need to specify this explicitly. Another thing that we need to tell the service when the API gateway will be hitting the service, that the service actually responding with gRPC protocol. So inside this service, which is standard Kubernetes service, I'm putting this annotation called gRPCS. So my service will be respond with the secure gRPC protocol. And let's take a look. So inside Insomnia, I will be able to also get access to this gRPC service. And one of the things many people needs to have is a protofile in order to understand how this service is communicating. Thanks to Insomnia built-in feature, we can discover what kind of services available. So when I go to this IP address, I can go refresh and I see methods available. So there's some health checks, there's some information, like if I will call the health check, I'll get the response, it's up, status is okay. But I'm more interested in quotes. And more importantly, I'm interested in streaming. So when I will subscribe this, I don't know what is this. So my Insomnia sends me my gRPC service sends my responses from the Dune service, and everything goes through from my Ingress controller, from my con gateway. Sorry. So if I will go here, I see this is service that I'm serving. We gRPC, and my routes connect also recognizes this is a gRPC service, and we're getting some data here. So now to the point of not only L7 traffic. So I do have a UDP service, and unfortunately for some of us, but maybe fortunately for others, Ingress doesn't support UDP. It doesn't know what to do with this because it was created before. Before all these things become a requirement for people to run. Not many people thinking that they will ever run UDP service inside Kubernetes cluster, but think about this. If you're running DNS service and you want to expose this for Kubernetes, DNS service also talks through UDP. So inside the Quonk, now we're going into a little bit on a vendor-specific configuration, but stay tuned. I will talk about independent things also. When we go into vendor-specific, we have a UDP Ingress. So UDP Ingress allows us, it has the same semantics that our standard Ingress has, but only thing that matter for UDP thing. And in this case, I have my UDP quote service that will be responding with some data. So the way how it works slightly different. So if I'm going into my conc namespace for UDP service, I have separate listener. As you can see here, this proxy only serves L7 protocols, but also another listener will serve a streaming protocols. And 64, it's our UDP server. So if I'll do something like a netcat and try to hit this, now my ingress will be serving UDP traffic throughout the from within the Kubernetes cluster. So here's the answer for L4 traffic. So the question is that like why people want to use gRPC. It's quite popular right now in the mobile world, where you can expose your services through gRPC. It has a slightly tiny size of payload comparing to the text-based protocols like REST. It has a streaming capabilities that I showed you, like server-side can constantly pushing your stream back, and all these nice features. So gRPC is great. Again, let us know if you want to learn more about gRPC, and we might come up with some materials here. Now, before we part, let me talking about one last thing. When I was talking about this ingress, I mentioned that ingress there's no way to configure what actually running underneath, what kind of gateways you're running there, and things like that. So Gateway API is the new specification that coming into Kubernetes. It will become a new standard and allows you to configure and have a more decoupled control over your routes, because you're defining your routes, even though you're redefining your routes as a HTTP route or host name or header or whatever, and how this access to your service. And you will be able to configure different gateway implementations. If I will just do so right now, get gateways. So there's no gateways. I didn't deploy any gateways things, but I will show you how we can. I will show you how we can do that in a second. So the Gateway API is actually thing that you want to in your cluster, because it allows you to have a clear separation of concerns between developers and operators. And by operators, I mean like human operators, SREs, who will be responsible for maintaining this infrastructure. As a developer, you will be responsible only for defining this like HTTP routes and things like that. I did a series of quite extensive demos around this Gateway API, and I'll tell you where you can find those. Where you can find all these things. Kong YouTube channel has extensive collection of the videos, demos around the things. There's a gateway explainer, has a gateway with gRPC. So all these kind of things can be found on the Kong YouTube channel. You can scan this QR code. If you're watching on the screen, you can go on the phone, should route you to your YouTube application. Inside this YouTube application, you need to go and say, I want to subscribe and enable notifications. The way how it looks like, you go in here, YouTube, Kong YouTube channel, you go in something like this, go in subscribed, and make sure that your notification is enabled, so you will have new fresh videos from us. So join us for some of the in our communities. Join us for Kong Builders. I'm doing the live streams, not tech talks on our YouTube channel. So those things will be very cool to watch. So again, stick around for more content like this if you're into cloud native API management and the cloud native connectivity. My name is Viktor Gamov, and as always, have a wonderful day.